Okay, good morning. So we start the lesson today. Of course, the lesson today is optimization, which is the last part left from this chapter. But optimization actually relates to what I told you in the previous session. And if you remember, there was one problem left from that session. So let us start doing this one first, and then to refresh your memory, and then we start the new lesson. Essentially, the new lesson, the first part of the new lesson is different. You need to make up the function and the interval yourself. As soon as you come up with these two, the rest of the problem would be exactly this exercise or similar exercises. Okay, so here, if you remember, we want to find the absolute max and mean of this function on this given interval. Yes, so what we have to do, if you remember, the first thing that we do is to differentiate the function, so it becomes f prime of x is equal to the derivative of e to power x is itself, the derivative of minus 3x is minus 3, and the derivative of 2 is 0. So as simple as that. Then you have to put this equal to 0. Then this then implies that e to power x minus 3 is equal to 0. I move 3 to the right hand side, e to the power of x becomes positive 3, and hopefully you remember that if I want to find x becomes ln of 3. Yes. Okay, by the way, I have been a little bit in hurry. Before accepting this, I have to check it here. Is this number that I get from solving this equation actually exists in this interval? If you have, for example, your calculator, you can immediately see that yes, this is here. And of course, because 3, we talked about this before, because 3 is bigger than 1, ln of 3 is bigger than ln of 1, and ln of 1 is 0. So ln of 3 is definitely bigger than 0, so it is positive. But it is clear, if you remember, that e is around 2.7 something, and then we know that 3 is less than e to power 2. This is for sure, yes. E to power 2 is definitely bigger than 3. So then it means that ln of 3 is smaller than ln of e squared. But you know that this 2 goes behind, so it becomes 2 ln of e, but ln of e is 2. Ln of e is 1, so the whole answer becomes 2. So it means ln of 3 is indeed smaller than 2. So without calculator, that's also possible to confirm that this number is within this interval. Yes. Okay. Anyway, but you can use your calculator, of course. Let me make my calculator ready here. Or we can use Geogebra. Okay, so now what we were supposed to do you remember? We are supposed to calculate the value of the function at this point that we get here and the final points. And of course we have to pay attention that this one is excluded. If necessary, it might happen that the interpretation will be different. So let us start calculating this. The first thing that I calculate is f of this number that I got. It means that in this function I replace x with this value everywhere. So there are two positions that x appears. So I would write x e to the power of ln of 3 minus 3 times ln of 3 minus 2. But hopefully you remember this formula that e to power ln of any number is equal to that number itself. So then it means that e to power ln of 3 is just 3, and then I have minus 3 ln of 3 minus 2. So the answer becomes 3 minus 2 is 1, minus 3 ln of 3. So we have to keep the values exact, okay? So we're not supposed to approximate unless it is demanded in the problem itself. Okay, so this is one value, and the other value is f of minus 4 so I have to calculate that. It becomes e to power minus 4. I replace x with minus 4 everywhere, minus 2, but this part is positive 12, and then I have negative 2, it becomes positive 10, so then it becomes positive 10 plus e to power minus 4. So this is also another answer here. And then finally, even though, do you remember, even though 2 is excluded, we calculate to see what happens. It becomes e to power 2 minus 3 times 2. I am replacing x with 2. Oh, sorry. I'm replacing x with 2, and then the answer becomes e to power 2 minus 6 minus 2 is minus 8. Okay, so these are three numbers that I have to compare with. So the numbers here and here and here. So these three numbers, the maximum one, the biggest one is the maximum, the smallest one is the minimum. And if one of them, either the maximum or the minimum, is attained at 2, because 2 is excluded, then we will say that that number, if maximum or minimum, does not exist. But we have to compare these three numbers. Okay, so how we can compare these three numbers? Here, of course, it's easier to use the calculator, yes? So we have these three numbers. So let me go to Geogebra and try to punch these numbers in Geogebra to see how it's going. So I don't know if Geogebra gives you the approximate value. I think it will. So it becomes 1 minus 3 ln. You need to put brackets around that. Okay, so this is this number you see on the display. It's around minus 2.2, and then we go, of course, let us calculate e. So let us use this button, you know, if you e to power 2 minus 8, and this, oh sorry, I have to go down, minus 8, and this is this number. And of course it's clear that this should be positive 10 plus, again I use this bottom e to the power of minus 4. Yes, and this is this number. And then you immediately realize, of course it was clear from the beginning this should be the maximum. Yes, but this is the maximum value, 10 plus e to power minus 4, and of course this is the lowest value, yes, minus 2 point. So I don't need to be worried about this excluded point. So remember this order in your mind, so when I go back you don't have any trouble, okay? So what can I do? I will go here and see that so this one is the biggest value, yes? So maximum of f is 10 plus e to power minus 4. We have to keep it exact. Okay, and it is not part of the problem, so let me write it with the color. So it attained, let me just make it simple, attained at x equals to minus 4. So I don't have any problems with that because minus 4 is not excluded, it is included, so my function has a maximum indeed. And then which one was the minimum? This was 1 minus 3, yes, minus 3 ln of 3. So the minimum, does it exist? Yes, because this is attained when x is ln of 3, and it has nothing to do with this excluded point. So this is equal to 1 minus 3 ln of 3, and it is attained at x equals to ln of 3. So this is the answer that you need to provide here. Any questions? Okay, if you like these kinds of problems, try to convince yourself that this one is the biggest number and this one is the smallest number without using calculator. Okay, because I want to teach you more stuff. If we have time, I can come back and show how to do that. But here, let me continue the lesson. But please let me know if you have any questions. That's also a good exercise to go and sketch the graph of this function to see if everything fine. If you remember, if you want to draw the graph of the function using GeoGebra in an interval, it is better to start with this instruction if you have installed it in English. Otherwise, if it is in Swedish, you need to type different spellings, of course. So here you see there is a function, a start value, end value. So I press that one and I type my function. So my function was e, so let me use this e button, and then to the power of x, then I will go down minus 3x, yes, then minus 2, and then I use arrow keys to jump the other one, so it is minus 4, yes, and then it is 2. But of course GeoGebra is not capable of excluding one single point, so we do this. And this is the graph, and hopefully you realize it is very similar to a parabola, but from your mathematical knowledge you know that parabola should be a second-degree polynomial. Even though it looks like a parabola, definitely it is not. Okay, so this is the graph of the function. Because you see the maximum value is around 10, so I need to move this a little bit around so that we can see everything up to 10. Yes, so okay, so in my display at least you can see it's a little bit bigger than 10. You see 10 is exactly here, and this is 10.01, so that is the maximum point, and the minimum point occurs somewhere here, and it has nothing to do with this 2, which is excluded. Yes, let me see if we can use GeoGebra to find the extreme point. So I choose this one and I click here. Is there any? No, it's undefined. I don't know why GeoGebra is not capable of calculating the extreme points of that point of this curve. It shouldn't be hard for it. Okay, anyway, so okay, so now everything is confirmed. So now we go to the new lesson. Okay, what is the new lesson? The new lesson is actually a very practical, important lesson. So, and that is called optimization. Optimization sometimes means minimizing, sometimes means maximizing. Yes, according to what we want to do. So, for example, if the function that you are dealing with is your profit of what you sell, is probably your goal. Optimization here, maximizing your profit. But on the other hand, if you're dealing with a function that shows your loss in your business, then of course optimization here means minimizing. So optimization is actually two-folded word, yes, so it depends. Sometimes it's maximizing, sometimes it is minimizing. So I would say that by what you have at your disposal, you want to optimize something, either maximize it or minimize it. The first few examples, I am just dealing with mathematics, using these ideas within the mathematics itself. Then I will give you a little bit practical problem that you can use these ideas to solve some, I would say, practical problems. Okay, so let us start by examples. The best thing is probably doing examples. Example number 1. A wire 16 meters long has to be formed into a rectangle. What dimensions should the rectangle have for the largest area? Okay, so the question is clear. So I have a wire which is 16 meters long. My goal is to somehow bend it and form a rectangle using that. Of course, it is clear that you can have infinitely many rectangles. You can make your rectangles thin and long so that the whole perimeter is equal to 16 meters. You can make it a little bit fatter but shorter, so that again the whole circumference or perimeter is equal to 16. So there are infinitely many options available in front of us, and all of these rectangles are supposed to use exactly 16 meters of a wire that we have at our disposal. But for example, somehow it's a practical. If assume that you want to I don't know, you want to make a rectangle so that the area enclosed. So for example, assume that you want to put it around some stuff to separate it from what you don't need. Of course, it is better to maximize the area because it would be more room for more things in it. Yes, so that's optimization problem. So you don't want to spend more money to buy a longer wire, but in the same time you want to optimize, you want to benefit the most from what you have. Okay, so you see, this problem, optimization problems, are mainly written in words. There is no function. This is up to you to find the function and the interval on which this function for the problem in the context makes sense. Okay, so my advice is to see what you want to do at the end. You want to find the largest area. Okay, so it's better to sketch something for yourself. It's always helpful. For example, I know that I am supposed to put this wire into a rectangle. So let me just draw a typical rectangle here, assuming that its circumference is 16 meters long. But there is no one rectangle. I have different rectangles. So, my target, the function that I want to optimization on it, is the area. So it's a good name for area to call it A. I would call this area the target function. So you need to write a function for your target quantity. Your target quantity here is A, but I need to express it as a function. Okay, how can I write this down? I don't know. I need to give a name for the height, and I need to give a name for the, I don't know, length, and then I know what to write for the area. So the area is x times y. So at least I have something in my hand. This is my function. I want to maximize this. But there is some problem here. You have more than one variable in your function. Okay, so if I want to use the derivative, hopefully you understand this is related to derivative because you want to find the maximum of something, and we learned if you want to find the maximum of something, very good starting point is using derivative. And the derivative you can use when you have a function of one single variable, but you have two variables. But of course, on the other hand, these two variables are not free to take on any numbers they like. For example, can x takes 1000? Definitely not, because the whole perimeter is supposed to be 16 meters. So there are some limitations. This thing that we have at our disposal imposes some limitations to the values of these variables. Okay? So I have to use this constraint in an efficient way. How should I use that? Okay, you are telling me that the circumference is 16 meters. So it means that x plus y plus another x plus another y is 16 meters. So I write this information. So 2x here and here plus 2y up and down is equal to 16 meters. This I know. And then usually you see that whenever you can simplify things, it's much better to simplify that. So x plus y is 8. Okay, now your function can be written in terms of only one single variable. For example, if I eliminate y, so for example, if I find y, it becomes 8 minus x, and if I put this here in this equation, then a becomes equal to x instead of y. I put 8 minus x, and now this function, this area, is expressed solely in terms of x, so it is a function of x now. Okay, so I got it. This is my function that I want to minimize. Yes, this is my function to I want to maximize, but I also need an interval. But the interval is also not hard to understand. So is there any limitation for the value of x? The answer is clear. Yes, x cannot be negative, for example. X is the length here of some side of the rectangle. It cannot be negative. So x is at least equals to 0. Of course, it cannot also be equal to 0 in this case, because if x is equal to 0, it means that I haven't done anything. I have just won a wire. But can you tell me what is the maximum? How? What is the largest value somehow that we can get close to for x? It's 8, yes, because if x becomes bigger than 8, then y becomes negative. Again, for the same reason, y cannot be negative either, yes? So it means that, yes, there I have something between 0 and 8. So this is my interval. So this is the optimization problem. So what you want to do now is just exactly as what we did before. So now you can, when you are here, you can totally forget about the rest of the problem, and then you have a function, you have an interval, you want to find the maximum of this function on this interval. Okay, so this means that this becomes the lesson that we learned in the previous session, and I did an example about it to refresh your memory today. So what I have to do, I have to calculate the derivative. But before doing the derivative, because this is the product between two functions, I realize that I have to simplify it first by multiplying x in. So it becomes 8x minus x squared. Then I differentiate it, so it becomes 8 minus 2x. Then I put it equal to 0. This implies that 8 minus 2x is equal to 0. Then I simply get x is equal to 4. Is this 4 acceptable for me? I would say yes, this is acceptable for me. So why this is acceptable? Because it is in the interval, and then I keep it. And in principle, what should I do? I need to calculate a at the number that I get. What does it mean? It means that I go to my function, replace x with 4. So this becomes 4, 8 minus 4. Or of course, if you want to, you can put it here. It doesn't matter. But then the answer becomes how much? 16. Here you have to write the area, the units. So it was meter, so it becomes meters squared. And then of course I can calculate a at 0, a at 8. But what is a at 0? It is 0 times 8 minus 0, which is 0. And then 8, it is 8 times 8 minus 8, again 0. So I have 0 meters squared, 0 meters squared. So I have 3 numbers. One of them is this number. I have 2 zeros, of course. It is clear that the maximum is 16. Is the maximum is attained? Yes, because it occurs at 4. Yes? So what is wanted? The maximum area is not wanted. What dimensions should the rectangle have for the largest area? We realize the largest area possible for us is 16 meters squared, but when it is attained when x, my variable, is 4. Okay, so maximum of a is attained when x is equal to 4. And of course, when x is equal to 4 and I put it here, y also becomes 4. So it is a very nice thing. Might be, I don't know, could you predict it before calculation? So if you want to have the largest area, make a square out of it instead of a rectangle whose dimensions are different, because the calculation shows that if I want to have the largest area possible, x should be 4. When I put x equal to 4, y also becomes 4. So it means that indeed this is a square. Okay, so the answer that you need to provide for this answer, for this problem, is x should be equal to 4 equal to y meters. So this is the answer that you need to provide for this problem. Yes? Any questions? Of course, if the maximum and minimum occurs at these 2 points, they are not acceptable. But of course, you see that this is nothing actually you need to be worried about, because you are looking for the maximum, and maximum is 16. Okay, so that is one very simple problem of optimization. So what we can do to start solving more examples, okay? So number 2, among all pairs of non-negative numbers that add up to 5, find the pair that gives the largest value for the product of the square of the first number and the cube of the second number. Okay, so among all pairs of negative numbers that add up to 5. So I have 2 non-negative numbers, so let me call one of them x, the other one y. So let x and y be the numbers. Okay, this is completely algebraic problem. So we know that they are supposed to be non-negative. It's mentioned in the problem that they are supposed to add up to 5. So it means that what I know about x is that x is non-negative, y is non-negative, and we also know that the sum is equal to 5. How many numbers are there with these properties? Infinitely many. For example, one of them can be 1, the other 4, one of them 2, the other 3, one of them, I don't know, 1.1, the other 3.9, one of them 1.01, the other 0.99. There you can play around, you see. Hopefully you agree with me, there are infinitely many pairs so that they add up to 5, even though the numbers are non-negative. But I want to find a pair with that property that gives the largest value for the product of the square of the first number, if I consider x as the first number, and the cube of the second one. Okay, so what is my target function? Because my target function is a product, might be you agree with me that P is a good name. So what is my target function? It is the product of the square of the first number. If I assume that the first number is x, it is x squared multiplied by the cube of the second one. So this is my target quantity, yes? I want to maximize this quantity under this constraint, under this limitation, yes? So how should I do that? Again, the same story. Even though I have my function here, I have my target quantity written as equality, but again I am facing 2 unknowns, 2 variables. Okay, so I need to eliminate one of them in favor of the other one. Okay. Now you need to also learn to remember a little bit about technicalities, yes? Of course, it doesn't matter. I can eliminate x, I can eliminate y. If you don't mind, let me eliminate x in this case, and I will say that why this is easier in this case, even though it is not essential. Okay, so it's a little bit strange because usually we are used to keep x and express functions as a function of x, but this is our choice. It's not mandatory. So what I can do, then I will tell you why the other way around is a little bit algebraically harder. So what I do, I will eliminate x this time. So I would say that, okay, x plus y is equal to 5. Then I would say that x is equal to 5 minus y. And then if I plug it back, then the product becomes equal to, instead of x here, I put 5 minus y, then I have a square. So it's 5 minus y to the power of 2, and then you have a y to the power of 3 here. But don't be disturbed about the name of the y. If you want to, you can call them a and b or whatever. This is just serving, so this is not like when I write y is equal to f of x, we usually write y for the function. But here is just a variable. If you don't like x and y, you can call them a and b. Okay, and then if I want to write something in front of it, this is a function of y. So this is my target function now. Yes? And it is expressed in terms of y. But can y be any number that it likes? No. At least you immediately see there is a constraint here, that y should be non-negative. So it means that the interval is y non-negative. But is there something limitation for y from above? Again, yes, because if I increase y a lot, 5 minus y becomes negative, x becomes negative, but this is not allowed. So at most I can run y up to 5, not more, because if I increase it, then x becomes negative, which is not allowed. So you see, again the question is the same. I have a function, I have an interval, I want to do the same thing. So I have to differentiate it, equate it to 0, and the rest you know. But there is a technicality here that I want to describe it here for you. If I want to differentiate this, first I need to simplify my function. For simplifying my function, what I have to do, I have to expand this using a squaring pattern. Okay, so it becomes 25 to the first one to the 2 times the first one times the second one, plus the second one to the 2, and then y to the 3, and then finally you can multiply y to the 3 inside. So it becomes 25y to the 3 minus 10y to the 4, and finally y to the 5. Now hopefully you agree with me. If I have done it the other way around, so let me write with a different color. So assume that we usually follow what we usually do, eliminate y. Then I would write y equals to 5 minus x. Then I have to replace y with this quantity, so then my function p would be x to the 2 times 5 minus x to the 3. And then of course this is not a function of y, this would be a function of x. Okay, and now you see that because I want to differentiate, I want to expand this. Here I have to expand something to power 2, but here I have to expand something to power 3. Okay, and there is a formula which is always on the formula sheet, but probably people doesn't use it, and that is a minus b to power 3. It is a to the 3 minus 3a squared b plus 3ab squared and minus b to the 3. Of course, if I use this formula, let me write it down. So p of x becomes x squared. The first one to the 3 is 125. Yes, and then minus 3 times the first one to the 2 times the second one. If you do the calculations, becomes 75x, and then the other one becomes 15x squared, and then finally minus x cubed. And then first of all, you see that the calculation was a little bit harder. At least you need to remember this formula. If you don't, most of us remember this formula, but might be some of us has forgotten. Of course, if you've forgotten, you can multiply this by itself 3 times, or multiply it 2 times using a squaring pattern and then multiply it. But anyway, the calculation is a little bit longer. So this is very important. When you are dealing with optimization problems, think before doing going forward. Sometimes might be different methods will make calculations easier. I am not saying this is wrong. If we continue this solution, you will see finally the answers will match, and if we want, we can do that. But let me simplify it in case we want to do it. So it becomes 125x squared minus 75x to the power of 3, and then plus 15x to the power of 4 minus x to the power of 5. So if you see I have done some mistakes, please let me know. So you see that the calculations was harder if I have chosen to eliminate y. So why should I do that? So let me eliminate x and do the calculations easier. Now let us continue with this function, which was simpler. What I have to do, I have to differentiate the function. So this becomes 75y squared minus 400y to the 40y to the 3 plus 5y squared. Oops. Let me double check. This one is correct. This one is also correct. This one is also correct. Then what I have to do, I have to put p prime of y equals to 0. So then what does it mean? I have to write this equals to 0. But this is a fourth degree equation. You cannot solve it unless you are able to factorize it. But the factorization was not hard. This was positive. You see that immediately I can factor 5y squared out. From the first, let me write the last one first. If I factor this one out, there is y to the 2 left. And if I factor 5y squared out from here, it's minus 8y. Yes? And finally, if I factor 5y squared from here, it is 15. Equals to 0. Of course, this is easy to solve because either the first one is 0 or the second one is 0. But the second one you can use PQ or ABC formula, but let us refresh your memory a little bit about factorization. For me, factorization here is simpler because the numbers are easy to guess. I need two numbers whose sum is minus 8 and whose product is 15. It's clear that one of them is minus 3, the other one is minus 5. So it was easier than ABC or PQ formula, especially when the numbers are easy to guess. So if I ask you what are the answers, either this one is equal to 0, which gives you y equals to 0. This is one possible answer. Can I accept it? Yes, because it is within in the interval. So let me accept it. And the other one is y equals to 3. That is also acceptable. It is in the interval. And the other one is y equals to 5. That is also acceptable. Yes, y equals to 5. Okay, then what I have to do, I have to calculate the p at these numbers and the endpoints. But that is coincidentally, the endpoints are also here. So it's easy. So I need to calculate only 3 numbers. So p of 0, p of 3, p of 5. What is p of 0? Go back to your original function. Here. It's easier than to put it in the expanded version. Yes? In the expanded version, of course, you can put, but let us put it here. If y is equal to 0, this is totally gone. So this is 0. This is 0. And if I ask you what is p of 3, let me just put 3 here. Let me write it. It becomes 5 minus 3 to the power of 2 times 3 to power 3. But this becomes 4. This is 108. Yes? And what is p of 5? Again 0. Because if I put y equals to 5, this becomes 0. And then it is clear that the maximum value is 108. Okay, but what was the question? The question was find the pair that gives the largest value. Of course, the largest value that I can achieve is 108, but it occurs when x is equal to, sorry, no, the variable was y. Y is equal to 3. So I would say is attained for y equals to 3. But of course, if y is equal to 3, what can happen for x? 5 minus 3 is 2. So therefore, x is equal to 2. So what you need to provide for the answer is that x is equal to 2 and y is equal to 3. It was not easy to guess that these are the numbers. So it means that I have infinitely many pairs with these properties, but if I choose one of them to be 2, the other one to be 3, I will be able to maximize this type of product. Okay, so by the way, let me just mention that you actually achieved a lot of things. So because, for example, you have a bag, you find all pairs. For example, 1 and 4, 2 and 3, I don't know, 3.9 and 1.9. For all these pairs, you calculate this product and put it in this bag. How many dots you will get? You get infinitely many dots. It is not possible for us to check them one by one because there are infinitely many. But by this method, I say that, okay, don't spend so much time. Only the maximum number that you can see in this bag is 108, and when it is attained when one of them is 2, the other one is 3. The one that you want to raise it to power 3 should be 3. The one that you want to raise it to power 2 should be 2. Okay. But now, for example, if I wanted to continue with this method, this should also work, but might be the solution is harder. Let me see, especially the derivative. If I take the derivative here, it becomes 250x and then minus 225x squared. Then what happens is 60x to the power of 3 minus 5x to the power of 4. So you see that the equation that I have to solve is bigger than this equation, but I think it is still possible to solve it. I think I recommend you to solve it yourself. You can factor a 5x to the power 5x out still, but you will see that when I factor it out, by the way, I think it would be very hard if you want to do this wrong thing. If you are interested in these kinds of calculations, I recommend you to do that. But when I factor 5x out, what is left for me is a third degree equation. Okay? But here, when I factor this out, what was left for me is a second degree equation. So you see that even though technically if you continue you will get the same answer, but this one is much harder to manipulate than this one. Okay, so that is a good exercise to show the differences between these two. Okay, I recommend you to, if you like, try to solve this equation yourself and finalize this problem using this wrong, I would say, elimination. Any questions here? Okay, let us solve a problem in geometry. Find the height and radius of a cylinder of largest volume that can be inscribed in a sphere of radius square root of 3. Okay, so is the question clear? So I have a sphere whose radius is given to be square root of 3. Let me see if I can draw a picture. So something like that. For example, assume that this is your sphere to give you the feeling that this is a sphere. Let me just do something like this around that. Okay, so now you can feel that at least this is a sphere. Now the radius of this sphere, let me call it capital R, so this is a square root of 3. But now there are cylinders that you can inscribe in this. Inscribed means not putting it just here. It means that exactly touches the sphere, but it does not protrude out of it. Okay, it is, so it means that it touches the sphere, but it is still limited to be inside. So how many of these cylinders you can imagine? Infinitely many. Yes, for example, this is one of those cylinders. This is one of them, for example. I can make it a little bit thinner and longer. This is also one of them. I hope that you can imagine you can have infinitely many situations. We want to find the height and the radius of that one that has largest value. Largest volume. Okay, so how should I solve this problem? I would recommend you to start drawing one of them. For example, let me see, to try to do it properly if possible by hand. So for example here, let me just draw this. Hopefully it will work somehow, because by symmetry I need to keep it symmetric around the center somehow. Yes, something like that here, and let me for example draw it here, and then something like this here. Yeah, something like that. So this is the center of the sphere. Okay, so how should I solve this problem? Again, don't get confused. Read what is your target quantity. Your target quantity is the volume of this cylinder. You refer to the formula sheet if you have forgotten. Volume of a cylinder is equal to the pi number times its radius to power 2 times its height. Okay? And then again you are facing problems. Why? This is of course good because this is your target quantity. Pi of course is just a number, but R and H are variables because you see here R, the radius of the cylinder is that much, the height of this cylinder is that much. But if I make it a little bit fatter and shorter, what happens? Then the radius of the cylinder becomes bigger, and of course the height becomes smaller. But I want to convince you that there are infinitely many choices for R and H, and both of them are variables. I cannot solve this problem unless I know how to eliminate one of these variables. So here you need to ask yourself, how can I use this extra piece of information to find the connection between R and H? Okay, now I want to ask you, do you have any idea? So you see, the hard part in optimization problems is to come up with your function and interval. As soon as you are done with that part, everything is okay. You just follow the rules. Do you have any ideas? How can I connect R and H somehow? Do you remember here the connection was easy. It was expressed in the problem. They add to 5. So I have this simple constraint here. The constraint here is not as simple as before. You need to use your geometry knowledge to be able to connect R and H together. Do you see any way to do that by this poor picture of mine? In other words, how the radius of the cylinder and its height is related to the radius of the sphere. Okay, let me give you a hint. I will draw this for you. Let me change the color. I will draw this for you. Does this help? I will connect this point to this point here. Is it helpful now? No? Let me connect another line. the center of the circle for the base of the cylinder to the center of the sphere. Let me make it bigger to be able to draw the picture nicer. So sometimes these features does not work properly. I don't know how should I choose it. Anyway, you can think about it unless I am finding a way. No, this is not working. Let me try my chances once more. Yeah, that's better. Okay, can you tell me what is the length of this, I don't know what the color, purple. What is the length of this purple line segment? What is that? A square root of 3, exactly. So that's the square root of 3 because that's the radius of the sphere. And the radius of the sphere is mentioned to be square root of 3.
So you use the Pythagoras.
Yes, exactly. So what is this one? Can you tell me what is this length? This orange one, or I don't know, or this orange one or yellow one or whatever. So what is this one?
It's the height divided by 2.
Exactly, the height divided by 2. So I would write h divided by 2. And then finally, as you mentioned, let me just complete this one. This is also r, little r. And hopefully you agree with me that this is the Pythagoras theorem as you said. So let me make it better. So this is r, and this angle is 90 degrees, yes? So then it means that I can write the Pythagoras theorem here. I can use the Pythagoras theorem. So let us do it together. So what happens is that I can write a square root of 3 to power 2. So let me write it the other way around. H over 2 to the power of 2 plus r to the power of 2 is equal to square root of 3 to power 2. But the left hand side I can write it as h squared divided by 4 plus r squared is equal to 3. Now again, from the experience you got in the previous problem, that is up to you of course, and in principle both of them will work. If you want to solve this problem easier, do you go for eliminating r squared or do you go for eliminating h squared?
R squared.
Yes, you need to find r squared. Why? Because here r squared appears in my function. If I insist to find h, what I have to do, I have to multiply by 4 first. So for example, is 12, then I move this to the right, it becomes 12 minus 4 squared, then I have to take a square root, and by the way, the problem becomes a problem that you cannot solve it. This would be a problem for Math 4, you see, because you don't know how to differentiate this square root function. There is another thing below it, so this is not something that you can do it. But still at Math 3C level, even if you know how to solve it, why should I bother myself to go through differentiating the square roots? If you think a little bit, you can immediately realize that, okay, r squared is what I need. R squared is 3 minus h squared over 4. It's always better to think than just blindly go on. So then I will put r squared here. Then v becomes equal to pi. Instead of r squared, I put this expression and then multiply it by h. And then if I ask you what type of function is this, what is the variable in this function, the variable is h. Remember, this variable is now playing the role of your x usually. So and then I would write it as v of h is equal. So this is my target function expressed in terms of one single variable. But is there any limitation for h? Is there any limitation for h? Can you tell me? For example, it's completely clear h cannot be less than 0. Yes. H is the height. But is there any upper bound for h? I don't consider 0 because if h is 0, I will have just a flat, I don't know, I will get this circle. Yes, if h is 0, so you see when I am making h smaller, this would be the cylinder, the next one would be this one. Finally, if I make h equal to 0, this would be a degenerate actually cylinder. Anyway, so I will keep it a little bit above 0. But what is the highest value for h?
The 3.
No, 2 square root of 3, yes. Because this is h over 2, so the height cannot go beyond the diameter of the sphere. So it is 2 square root of 3. So at most it can go up to there. Okay, so you see now the problem is done. I have my function, I have my interval. But be careful, this h is playing the role of x. Okay, so now I want to differentiate that, but again, before differentiating that, I have to simplify my function, so I have to multiply pi and h inside. If you don't mind, pi is a constant, so let me not multiply it, make trouble for myself. I just multiply h, so it becomes 3h minus h to the 3 divided by 4. Now everything is ready to differentiate the function, so v prime of h is equal to pi is a constant, so I don't need to do anything with that. I just write it here, but I differentiate this function. When you want to differentiate this, as if you are differentiating 3x, because here h is your variable, so then it becomes 3. Here, if I want to differentiate it, so I need to write it as 1 over 4 h to the 3. H is playing the role of h, so the derivative is 1 over 4 times 3 h to power 2. So then it becomes 3/4 h to the 2. Yes? And then I put it equal to 0. If I put it equal to 0, it means that this should be equal to 0 because pi cannot be equal to 0. So this means this. And then what happens is that 3 over 4, let me multiply everything by 4 to get rid of the fraction. So it becomes 12 minus 3h squared is equal to 0. So minus 3h squared is negative 12. I divide by negative 3, it becomes positive 4. I get two answers, negative 2 or 2. But negative 2 is not acceptable, it is not in my interval, so not acceptable, not in the interval. Is this in the interval? Yes, because 2 square root of 3 is 1 point something, and 2 times that is bigger than 2. So h equals to 2 is acceptable. Now what I have to do, I have to calculate v of h. Of course here you need to, the units are not mentioned, so you can write a length unit or whatever. And then I need to calculate v of 2. So how should I calculate it? I need to go to my function and replace h with 2. So it becomes pi 3 minus 2 to the 2 divided by 4 times 2, which becomes, this is 1, 2, 4 pi. And then of course if I ask you what is v of 0, this part of the interval, because h is 0, this is totally gone. And then the other one, of course it is also clear it should be 0, yes. If I put this number here, this to power 2 is 12, because 2 to power 2 times 3, and divided by that is 3, 3 minus 3 is 0. Okay, so this is the maximum value. But what is wanted in the problem? The problem was finding h and r. Okay, so the maximum is this, but it is attained when my variable is 2. But what was my variable? My variable was height. So attained at h equals to 2. Okay, but when h is equal to 2, I am also supposed to find r. But finding r is easy, yes. I put this into this equation. So I would say that r squared is equal to 3 minus h squared divided by 4, but I found that h is 2. So this becomes 3 minus 1 is 2, but I want to find r. R is the square root of 2. Of course, it is clear it cannot be negative. So what you need to provide as the answer is that the radius is square root of 2 and the height of the cylinder should be 2 length units. Yes? Okay, is that understandable? So you see, somehow you need to be creative to think a little bit harder about the problem so that you can find your constraints in a way. Any questions? Okay. Let us see what we have here. What is the smallest perimeter possible for a rectangle whose area is 16 centimeters squared, and what are its dimensions? The reason I am just making this problem because, first of all, so far we have solved about maximum value. I told optimization means sometimes maximizing, sometimes minimizing. So this is one of those problems that you want to minimize. And there would be a little bit difficulty in this problem for some reasons that I want to mention about that. So, again, don't worry, let us read the problem. What is the smallest perimeter possible for a rectangle whose area is this? So it means that you have an area, you have a rectangle. So let me just draw a rectangle. Here, what I know about this rectangle is that its area is 16 centimeters squared. So for example, let me take this height x and I don't know this width to be y, and then what I know that the area is equals to 16. This means that x times y is equal to 16. So it means that I got my constraints between these two variables. They cannot be whatever they like to. The product has to be equal to 16. But I want to find the smallest perimeter circumference, yes, for the rectangle. Okay, so I think P is a good letter for denoting the perimeter. But if I ask you what is the perimeter, you know that I have two x's involved and two y's involved, yes? X plus y plus x plus y. But again, I have two variables. So here you need to think about to eliminating one of the variables from the equation of your constraint, yes? So here I don't have any preference, so I would prefer to eliminate y. So let me write it 16 over x. And I am on the safe side. I definitely know that x is not equal to 0, because if x was 0, the left hand side becomes 0, the right hand side becomes 16. So x is not 0, and I can safely divide by x, and then I can put it here. Then I will have my function. What is my function? It is 2 times x plus let me put it here. So 2x plus 2 times, instead of y, I put 16 over x. And then you immediately realize this is just a function of x. So p of x becomes equal to 2x plus 32 over x. This is my function. But now, can you talk a little bit about the interval? What is the x? What is the lowest bound? I don't know, the biggest lower bound for x. So I'm asking you, what can I write here? What can I write here? One of them should be very clear. What is that?
0.
0, yes. But what is the highest value? Is there any highest value that you can imagine for x? There is no highest value. Let me just describe it for you. Because from this constraint, let me divide by y. It becomes 16 over y. If I choose y equals to 1, what I get is 16. Let me make y smaller. Let me make it 0.1. Then what I get for x is 160. Let us make it even smaller. 0.01. Then this becomes 1600. Even smaller. So you see that by making y smaller and smaller, x values are going higher and higher. So there is no upper bound for the value for x. So if I ask you what is the maximum value that x can attain, you would say there is no maximum, but you can say more than that. You can say that there is no upper bound for the x value. So of course people just write it like this, but I want to compare it. Let me write with a warning y red and then put this in quotation mark, because you see infinity is not a number, so I cannot just treat it exactly like a number, but this is what we need to understand. So my interval is an unbounded interval. It goes from 0 to infinity. Okay, momentarily just leave it like that. Let us see what happens. So it means that now I have to take the derivative, but this is a fraction. If you want to differentiate fractions, what you need to do is to bring it up. These are the lessons that we had before. So this becomes 32x to the negative 1. And then what I differentiated, it becomes 2 minus 32x to the power of minus 2. But now because I want to solve equations, I prefer to write it right by positive exponents. And then I put it equal to 0. And I solve this equation. So 2 minus 32x squared is equal to 0. This means that 2 is equal to 32x squared. I multiply everything by x squared, so it becomes 2x squared is equal to 32. I divide by 2, it becomes 16. I take square root, it becomes negative 4, positive 4. Positive 4 is acceptable, it is within the interval, but this is not in the interval. Okay? And now the other point is this. This function, I have to calculate p of 4 as I did before. So I put 4 here. So it becomes 2 times 4 plus 32 over 4. So it is 8 plus 8, which is 16. Okay? But the problem is that what can I do with 0 and infinity? Infinity in this case is easier. So you see, let me write everything with red and put them in quotation mark, because infinity is not a number that you want to treat it with number, but it tells you something about the behavior. So can you tell me what happens if I increase the value of x to very big positive values? What happens for this function? So make x very big. What happens to this part?
It becomes smaller.
This becomes very small, and at the end, when it is infinitely big, it is negligible. But what happens for this one? It is infinitely big. Infinitely big plus negligible, it becomes infinitely big. Okay, and then what happens if I calculate p at 0? P at 0 is also something strange, yes? You see what happens, yes? Am I allowed to put 0 in my function? No, because the denominator becomes 0. But of course x is not exactly equal to 0, it's a little bit bigger than 0. Okay, but it means that I need to look at the limit of this function when x approaches 0 from the right. Do you remember this symbol that I put? It means that if this is 0, this is 1, I am getting close to 0 from the right hand side. Okay, and then can you tell me what happens? If I make x very small, what happens for this part? It becomes very small. At the end, it becomes negligible. But by making x smaller and smaller, I am making this very, very big. So at the end, p of 0 again becomes infinity. Yes? So now, what was my goal? My goal was to find the smallest parameter possible. At the boundaries, here and there, somehow I am approaching to infinity. At 4, I am getting 16. So it is easy to compare these three things and say that this is the minimum. Okay? So this is one way to understand that this is a minimum. Another way to understand that this is a minimum, because that is the only, candidate of max. So for example, do you remember when I put the derivative equal to 0, what I get are possible candidates for maximum and minimum. But there is only one unique candidate. So if it is a maximum, then it is the absolute maximum. If it is a minimum, it is the absolute minimum. So another way, I will consider this a good way. I don't have anything against that. But you see that I have to put a lot of things in quotation marks because officially you haven't studied these things. Then another way, let me write it with a different color. So here, what I do, either I need to set up the table to see if this is indeed a minimum, checking this, what is the derivative before that and after that, and you will get this one. But do you remember we had another one, second derivative test, and this function is so simple that I try to use the second derivative test. So from here, I take another derivative, it becomes 0 plus 64 x to the power of minus 3. I simplify it, it becomes 64 divided by x to the 3. So this is my second derivative. Do you remember the content? If I am lucky and when I put this number 4 inside, it is not 0, then I can conclude. If I put 4 there, it becomes 64 divided by 4 to the 3, which is 1. And 1 is positive. Do you remember when the answer is positive, it means that that point corresponds to a local minimum. And this function after 0 is continuous. You see that when I am getting close to 0, it becomes huge. When I get close to infinity, it becomes huge. And then there is one point that it touches the local minimum. So that local minimum should also be the absolute minimum. And this also confirms that this corresponds to a local minimum, not a local maximum. Okay? So let me draw this graph by Geogebra, 2x plus 10. But let me finalize the problem. What was the problem? The problem is that what is the smallest parameter possible here, and what are the dimensions? So what are the dimensions? X is equal to 4. X is equal. So what is the lowest parameter? The lowest, the minimum. The smallest, yes, the smallest parameter is 16. Is it in terms of what? Centimeters. So it is 16 centimeters. What's this doing? I don't know. Centimeters. And then it occurs when x is equal to 4. And what happens if x is equal to 4? I put it here. Y is also 4. This is also nice, yes? It means that you need to make it again square. So if the here, do you remember, if if the area is fixed, to have the minimum circumference, you need to make it a square. In the first problem, if the perimeter is fixed, to make the area maximum, again, you need to make it a square. So it is a nice analogy between these two problems. Okay. Okay, let me just draw this graph with GeoGebra to see what happens. So we go here, 2x plus 32 over x. So if you don't mind, let me just draw the whole graph. It is not continuous, so definitely the graph will be two parts, but you can immediately ignore one of them. So here, let me just write the graph. The graph is y equals to 2x plus 32 over x. Is it writing or not? Yes. Here. So I don't know what happened. Oh, it's up there. Okay. So you see the graph is two parts. Forget about this because this part is on the negative side of x, but we know that x cannot be negative. So let me just zoom in and concentrate here about the graph. So here you see it doesn't matter. So from the right hand side, if x approaches 0, it is getting close to 0. You see it goes higher and higher indefinitely. It doesn't matter how much I go higher and higher. You see it's still coming with me. Yes. Yeah. And then it doesn't matter how much I go to the right, it also goes up and up. It doesn't matter. Of course, there is no guarantee for that, but from mathematical point of view, we are guaranteed there is no turning point. There was one single turning point for this function, and that single turning point occurs when x is equal to 4, and I think you immediately realize it is also confirmed by GeoGebra. Let me, this GeoGebra can do this one at least, or not for us. Yes, this is the extreme point. It occurs at 4 and its minimum value is 16. So what we have actually got is exactly the correct answer. Okay, now I see the time is more or less finished. There is one problem left. Okay, so this is also a very nice problem. I want to show it to you and you can take a screenshot, and I would recommend you to think about that. Again, next time I will start from this one and I will give you time to work on these questions. We need to find a time, by the way, for the exam. So let us just do this. Can you take a screenshot if you want to work on it? Because I want to stop sharing. So thank you for listening. So let me just stop.